So let's talk about factor by grouping. So this is a factoring technique that you're going to want to use whenever you're trying to factor something that has 4 terms. So we have this polynomial here on the screen, x cubed plus x squared plus 9x plus 9. So it's a pretty straightforward example. So whenever you're doing factoring by grouping, what you want to do is you want to create 2 groups. So what you're going to do first is you're going to cut your equation in half. So then you're going to look for a GCF on both sides. So on my first side, on the left, I have x cubed and x squared. So they both have x's in them, and specifically, I can take an x squared out of both of them. So my GCF here is x squared, so I'm going to put that in the front, and then I'm going to write what's left over from that group if I take that away. So if I take 2 x's away from x cubed, I have 1 x left over, and if I take x squared away from x squared, I'm left with a 1. So in my second group, my GCF is, I have 9x plus 9, so they are both divisible by 9. And I'm going to take out a positive 9 because this is positive. And then again, I'm going to write what's left over. So if I take 9 away from 9x, I'm left with x, and 9 divided by 9 is 1. So it's really good that it works out this way because we need both of these things to happen. So you want the group that's left over from both parts to be exactly the same. So now because both parts of the equation have a common group, what we're technically going to do is we're going to factor that common group out to the front. So we're going to factor that away from both parts of the equation. And then what we're left over with is our 2 GCF. So if I take x plus 1 away from the first half of the equation, I'm left with my GCF of x squared. And then if I take it away from the second half of the equation, I'm left with that plus 9. And then since we're just factoring, we want to check and make sure that we don't have any difference of squares popping up, which we don't. We have a sum of squares in the back, right? We have x squared plus 9, but you can't factor x squared plus 9, so we can leave this alone.